Okay, what we're about to do now is dealing with something called asymptotes. Asymptotes are curves that approach a particular point on an axis without actually getting there. So it looks like a gigantic straight line if you use your calculator graphing system, but it goes up, and then so a lot of times all of a sudden one appears on the bottom of your screen, comes back up and goes away from it. So that is usually indicative of an asymptote, that a number cannot be approached. And there's two ways that this is taken care of. An asymptote is usually the result of an impossibility that cannot be resolved. In other words, it's not removable. If you have a removable part, then what you can do is have the whole line up to that point, and then you have what we call a hole, where it's not allowed to be at that point, and then the continuation. It's a discontinuous graph at that particular point. The vertical asymptote is still a discontinuous graph at a particular point, but it's shown differently. It moves towards it and then away from it, or away from it and then towards it, depending upon which direction you're going from. So what I want to do is show you a quick way of determining these vertical asymptotes. So let's take a look on page 88, problem number 9. And we're looking here at the function of x is equal to 1 over x squared. Now, sometimes you can do this, sometimes you don't have to do it, but particularly when you're first starting this, you probably should graph these things so you can see what they look like. So I would suggest you go ahead and go to y equals and go to y1 and type in 1 divided by x squared, and then go to zoom and hit 6 to make sure it's in the default window, and take a look at it. And you'll see that there is indeed a vertical asymptote there, but we don't have to do that because the denominator tells us. We cannot have 0 for a denominator. So if x squared equals 0, then that means that x equals 0. And therefore that is not attainable. And since this is not removable at all, that is going to create a vertical asymptote. So this is the equation for a vertical asymptote. Okay? It's that simple, but there's going to be little hiccups here and there, but that's basically what we're doing. We're looking at the denominator, and then we're trying to see if there's a vertical asymptote there. If it's removable, and there's still other vertical asymptotes involved, then we will identify those. Okay? So, let's take a look at number 11. For this one, it's h of x is equal to x squared minus 2 over x squared minus x minus 2. So here's where your factoring skills come into play. We can't factor this, it's not a difference. Well, we could factor it, but it's not going to do any good because we're going to get a radical 2. You get x minus radical 2 times x plus radical 2. It has nothing to do with what's going on down here, because we're trying to find a way to remove aspects of this denominator to at least just have a hole there instead of an asymptote. So we're going to factor this. This is factorable. What two numbers multiply to give you negative 2 that add up to positive 1? Well, that would be negative 2 and 1. So we're going to replace this with the binomial pair of x minus 2 times x plus 1. And this is going to give us our vertical asymptotes because, again, if a factor equals 0, then the whole thing equals 0. So we said x minus 2 equal to 0, which means x equals 2, and x plus 1 equals to 0, so that means x equals negative 1. So that means the lines x equal 2 and x equals negative 1 are impossible, and therefore these are our vertical asymptotes. So in this particular case, we have 2 vertical asymptotes. Okay? Number 13. We have f of x is equal to x squared over x squared minus 4. And yes, this does indeed have a factorable denominator here. And That is the difference in squares, and we would get nice rational numbers. But even if it wasn't nice rational numbers, we can still use it. I mean, that's really immaterial. There's nothing to cancel out up here, because you can't cancel out x squared and x squared, because x squared is not multiplying the -4, it's adding to the -4. So we just factor this out, you get x minus 2 times x plus 2, and since we can't, cancel anything out, that tells us our two asymptotes right off the top. X equals 2, x equals -2, vertical asymptote, vertical asymptote. There we have it. See? Pretty good, huh? So certainly it's not going to get much more difficult than that. Number 15. Number 15, g of t equals t minus 1 over t squared plus 1. Now, is this factorable? No, but if you notice something very interesting about this, t squared plus 1, the lowest number that any square could be is 0. Anything that's any negative value put in for t is going to be a positive value. So there's no possible way that you're going to get 0 for the denominator. So there will be no vertical asymptotes. Okay? Now, 17 is a